Ladies and gentlemen, the world's most powerful rocket right here.
Hello everyone, and welcome back to the Fluctus Channel. NASA is building the world's most powerful rocket, bigger than the Saturn V that took humans to the moon in 1969.
And about 2 or 3 or maybe 4 easy phases can bring you.
The Space Launch System, or SLS, is the most advanced and powerful rocket to date, and it is creating a paradigm shift in deep space explorations. Building this Colossus machine is no small feat. And engineers at NASA work around the clock in cutting-edge factories, priming the SLS for future missions to the moon and beyond. NASA has been the cornerstone of aeronautics and space exploration since its inception in 1958 under the governance of President Eisenhower. From Project Mercury to Apollo missions, the Space Shuttle program, and the International Space Station, NASA has become the global pioneer in space exploration. Rockets like the Saturn V and Atlas V remain titans in heavy-lift launch vehicles operated under NASA.
From the Atlas V rock space.
NASA is leveraging decades of expertise gained in high-lift vehicles to manufacture the world's most powerful rocket, the Space Launch System.
Other way.
This super heavy-lift rocket is a true powerhouse,
-15.
packed with 8.8 million pounds of launch thrust.
4, 3, 2, 1, fire.
The core stage is 212 feet tall and holds 733,000 gallons of supercooled liquid hydrogen and liquid oxygen to fuel its 4 RS-25 liquid propellant engines. These 4 engines fire for 8 minutes, delivering a whopping thrust of 2 million pounds to take the rocket to the edge of space, passing the Kármán line. The core stage provides the required initial velocity for the spacecraft to enter the orbit towards the moon. Boeing manufactures the core stage in NASA's Michoud assembly facility in New Orleans, along with the avionics placed inside the forward skirt that acts as the rocket's brain. The core stage has 2 5-segment solid rocket boosters attached, providing more than 75% of the total thrust during the first 2 minutes of the launch. Each booster delivers 3.6 million pounds of thrust and becomes the most powerful and largest solid rocket booster ever manufactured. Unlike the boosters from the Space Shuttle program, these booster stages are not recovered and are designed for single use only. Depending on the mission, the core stage sports either the Orion crew module or the payload. Following the separation of the core stage, the second stage of the rocket, the Interim Cryogenic Propulsion Stage, or ICPS, provides the in-space propulsion to the upper stage. The ICPS detaches from the spacecraft after the translunar injection burn, which is the final push to the spacecraft towards the lunar orbit. NASA is building on the experience gathered from past missions and utilizing cutting-edge technologies such as 3D printing and structured light scanning during the manufacturing process of SLS. The friction stir welding tool is one such key piece of equipment used for welding the launch vehicle stage adapter to the core stage. This stage adapter connects the second stage, which carries the interim cryogenic propulsion stage to the core stage.
And liftoff of Artemis 1.
The Artemis 1 mission used an SLS rocket from the Block 1 configuration, and the same configuration will be used for the upcoming Artemis 2 and 3 missions as well. The core stage comprises 5 major sections: forward skirt, liquid oxygen tank, intertank, liquid hydrogen tank, and engine section. The Michoud assembly facility in New Orleans serves as the hub for assembling these sections. The technicians and engineers at the Michoud assembly facility weld or bolt these sections to complete the core stage for the Artemis 2 mission, the first crewed mission of the Artemis program. The Michoud assembly facility has aptly named the America's Rocket Factory as a tribute to its contribution to manufacturing space vehicles since the 1960s. The facility manufactured the first stages of the Saturn rockets for all Apollo missions and 135 external tanks for the Space Shuttle program. The state-owned facility extends over an area of 43 acres and is home to many NASA contractors, including Boeing and Lockheed Martin. In addition to the Michoud assembly facility, NASA relies on the Marshall Space Flight Center and Stennis Space Center for simulating flight conditions and comprehensive structural testing of SLS components. Moving these oversized components between the centers presents unique logistical challenges, requiring specialized transportation platforms. The largest section of the core stage is the liquid hydrogen tank that holds 537,000 gallons. The technicians at NASA move such structural components to the Marshall Space Flight Center for testing via a barge named Pegasus. The special test stand has 38 hydraulic pistons that push against the tank wall to simulate flight loads. NASA uses the same barge to transport the completed core stage to the Stennis Space Center for wet dress rehearsal. During the wet dress rehearsal, engineers place the core stage atop the test stand and fill it up with cryogenic fuel. During the test, engineers conduct a comprehensive test on each system, including loading and unloading of fuel, structural response, operation of avionics, and engine steering for thrust vector control.
Wet dress rehearsal is essentially launch without a launch. It is to really, the reason we're doing it is to verify and validate all of the pieces that go into launch countdown. So wet dress is really our opportunity to find any issues or adjustments that we need to make in our launch countdown.
Upon completing the test phase, Pegasus transports the core stage to the Kennedy Space Center, where it takes flight. To ensure a successful launch, the Kennedy Space Center also undergoes certain tests. One such test is the water deluge system test done at the Launchpad. The system discharges 450,000 gallons of water to the mobile launch platform and the flame deflector during the launch. A 290-foot-tall water-holding tank supplies the required water. The reason behind the deluge test is to absorb the immense heat generated by the engines. In addition to heat absorption, water acts as an acoustic absorber to reduce high noise and vibration. The water deluge test confirms the correct operation of the ignition overpressure and sound suppression system that protects the rocket from severe heat and noise during the launch.
Boosters in ignition. And liftoff of Artemis 1. We rise together, back to the moon and beyond.
While the Artemis campaign is set to expand space exploration to a new height, the James Webb Space Telescope, launched by the Ariane 5 rocket, opened opportunities to unlock the hidden secrets of the universe with an infrared eye. Ariane 5 is Europe's heavy-lift space launch rocket that flew 117 missions between 1996 and 2023. In December 2021, the Ariane 5 rocket flew from the Ariane Space Spaceport in French Guiana, carrying the James Webb Telescope, the world's largest space telescope. The telescope was placed inside the nose cone of the launch vehicle in a folded launch configuration. The James Webb mission stands as a solid testimony to the importance of international partnerships in space missions. Out of 3 partners, NASA, European Space Agency, and Canadian Space Agency, NASA held the overall responsibility of the mission. NASA contracted Northrop Grumman to build key components of the telescope. The telescope was assembled at the Northrop Grumman's facilities in Redondo Beach, California. NASA Goddard Space Flight Center managed the project and conducted tests of the telescope instrument. In addition, the most vital part of the telescope, the mirrors, were gold-coated at the Goddard Space Flight Center. The core challenge of the entire logistic operations was transporting the full-scale telescope to the Ariane 5 launch site in the Guiana Space Center in French Guiana. NASA developed a special suitcase named STARS, which stands for Space Telescope Transporter for Air, Road, and Sea, to survive the 5,800-mile journey from California to Guyana. STARS served as a mobile clean room to keep the telescope free from contamination. The James Webb program surmounted both technical and financial challenges, and its successful completion exemplifies NASA's unwavering commitment to advancing space exploration. Their state-of-the-art launch systems and innovative technologies will keep pushing the boundaries of humanity, paving the way for a brighter future for all.
And we have engine start. And liftoff.
Décollage.
Décollage, liftoff from a tropical rainforest to the edge of time itself. James Webb begins a voyage back to
That's the end of this video. I hope you enjoyed it. Make sure to subscribe to this channel so you don't miss any of our new content. See you next time.
Pitch program reported.